Robot Talk is the podcast that sits down with robot enthusiasts from around the world and asks them the questions you always wanted answered. Like, can robots help us recycle? And how does that thing work? Hello everyone! Welcome to Robot Talk. I'm your host, Claire Asher, and this week we're returning to the topic of manufacturing robotics. But this time, I'm learning about robots that work at the other end of the process, disassembling old products and recovering useful materials from them. But first, I'd like to remind you that you can send in questions for my future guests. And there are a few different ways you can do that. You can submit questions on the website at robottalk.org or on Patreon at patreon.com/Claire Asher. Or you can contact me on social media at Robot Talk Pod. So, without further ado, it's time for me to introduce this week's guest. I recently had a great chat with Josie Gotz from the Manufacturing Technology Centre about robotics for material recovery, reuse, and recycling. This week, I'm chatting to Josie Gotz, a senior research engineer at the Manufacturing Technology Centre, working on robotic automation for material recovery, reuse, and recycling. Hi Josie, great to have you on the podcast.
Hello, thanks so much for having me.
So you work in the Intelligent Robotics Team at the Manufacturing Technology Centre. So to get us started, can you tell us a little bit about the centre and the robotics projects that you're working on there?
Yeah, so the Manufacturing Technology Centre is part of the wider Catapult network, the High Value Manufacturing Catapult network, which is UK-wide. We're just one of, I think, 9 centres across the UK. And really, they've been set up together with the government and industry and universities to help UK manufacturing or British manufacturing in general. The different centres tend to have different remits, but at the Manufacturing Technology Centre, we focus very generally on manufacturing. So that's manufacturing processes, procedures. It can range from component manufacturing, like additive manufacturing.
That's 3D printing.
Yeah, 3D printing, exactly. All the way through to laser processing and, general manufacturing. Then we also look at like supply chain resilience and business transformation. It's as much as developing new technologies as pushing technologies which are already out into business.
Okay.
And the catapults have been set up, with universities in mind to help bridge what is known as like the valley of death in technology. So technologies are ideas and concepts which come out of university. They often have great, have legs, have funding, and then they die there because the funding stops and someone isn't willing to take it on and take the risk, or there isn't like the money to back them to take it on and bring it forward and get it ready for industry. So that's where the catapult centres have been set up. And we have like a 1/3 funding model. So we get a third of our money comes from the government. And the idea is that we can then help push some of those technologies out into industry. And we have lots of, industry partners and a membership model where companies can join and join the different catapult centres or join the Manufacturing Technology Centre and pool their money to put the money towards different research projects throughout that year.
Okay.
And the idea is that we're trying to pull those ideas or those research from university into industry along the way. And then we also work, on CR&D or collaborative research and development projects. So that might be together with businesses or other research partners, universities, and large industry partners, trying to bring them all together. And then we also, some of our funding comes directly from industry. So it's just with us working in a similar way as a consultancy directly with the industry. So what that means, I guess, for robotics, it's like very, very broad what we could be working on at any one time. And, in some industries, they're very advanced in robotics. So, the automotive is the classic example where there's been a very high uptake in robotics. However, you look at the food and drink sector, there's a very low uptake in robotics, and Britain in particular has a very low automation and robotics uptake compared to other countries. So sometimes that's about developing like very novel and new robotic processes and technologies, but it can also just be about trying to push automation into industry where it maybe isn't being used, or there's people are nervous about adopting it or have had failed, past experiences with it. So trying to get it out into those industries and see how we can adopt it successfully.
Okay. I mean, it sounds like a really fascinating place to work, a very kind of varied repertoire of stuff that you get to work on.
Yeah, it is very varied. I guess my personal interest is around recycling and recovery and how we can use automation for material recovery and recycling. One project in particular that I'm working on is looking at battery disassembly, so electric vehicle batteries. Obviously, when vehicles come to the end of their life, those materials within the battery are considered critical materials to us because we don't have a supply of them here in the country. They're also quite dangerous to disassemble. You don't know what state they've been in, if they've been in a crash, or if they're fully charged, it's high voltage. So we're looking at how we can use automation and developing the different automation techniques that you would need to disassemble them.
Fantastic. I mean, this is why I was excited to have you on the podcast, because one area I'm really passionate about is this idea of the circular economy, which for listeners who aren't familiar, is kind of the idea of minimizing or, ideally eliminating waste by keeping materials in use rather than sending them to landfill. And before I kind of started doing the podcast, when I didn't know anything about robotics, like I had this idea that robotic recycling should be everywhere, right? Like that this was a really obvious and great use of robotics. But so far, I've found it really hard to find people who work on robotic recycling. I've found it really hard to find examples. So, I'm excited to chat to you about this. Can you talk a little bit about the current state of the art when it comes to robotic recycling?
Yeah, so I would say you're right. It is difficult to find like good, obvious examples of where there is actually automation or robotics specifically being used in recycling. So there is obviously a lot. If you go to a recycling or a sorting plant where you're looking at your dry recycling that comes out of your blue bin, I would be doing a disservice to them, or even to say that they don't use automation robotics. The process is highly automated all the way through pretty much. So they sort you sort by shape, by size, by material. There's lots of different types of like general automation, whether that's air blasting or trommels or, sifters, conveyors, whatever it might be. Where a robot, or what we would imagine like a 6-axis robot or a SCARA robot, whatever it happens to be, tends to be at the end of the line.
Okay.
At the moment, and that I would say is coming in much more prominently within recycling centres, where typically people would be picking out and refining those last bits of recycling that are coming down. And this is where, the advancements with AI technology and vision detection have been brilliant, because now you can combine, vision systems to identify, okay, that's plastic, PET, that's the Coca-Cola can, that's cardboard. And then you have a robot which can quickly go in and pick those and sort them into the right bins, or, into the next conveyor, whatever it happens to be. But that's very much end of line sorting. It's like the last process, everything upstream of there is either done with like general automation or different types of automation that aren't what we would consider like a robot, say. Or by people at this stage, because it's still very difficult to get a robot to deal with the huge amount of variation that comes into a recycling process or a repair process, whatever that happens to be. So yeah, you don't see it so much in, I guess, where we're looking. We're like much earlier on in the stages of research and development, that developing a commercial product or a commercial solution for disassembly is still a way off in general.
Yeah. I guess the example you gave of the battery is a little bit different because it's, you know, it's got all these different components that need to be taken apart rather than just kind of sorting plastic into different types or, you know, that kind of thing.
Yeah, exactly. So, for example, with the batteries, what you're really looking at is the upstream process before it goes into a recycling plant. And ultimately, if we don't disassemble them properly, you know, whether that's manually or with automation, with a robot, then you risk the batteries having to be chucked whole into a shredder. And they go through like a chemical recycling process to extract the different elements that you want. And so you fine tune your recycling process for lithium, say, if that's what you're aiming for. But that means you essentially burn off everything else.
Yeah.
Which is very wasteful.
Yeah.
But because the return on investment on the lithium is what you're aiming for, that's like all you end up doing. So that's what we're trying to avoid, is that if we can create a process which, you know, you can help to disassemble the batteries quicker into its different elements, then maybe you can look at reusing the modules. You know, once you get it down to individual module or cell level, then some of those modules might well be healthy and they could be used for, say, battery storage or, you know, maybe they couldn't be used still in a car. But if you could test them, then they do have second life uses rather than immediately going for recycling, you know, and material recycling. Which I guess if you look at your recycling triangle, you know, you want to reduce or reuse the material before you want to recycle it.
Yeah, yeah. Okay. And so, you know, what are the biggest challenges with taking this from research to something that's commercially, you know, usable?
Yeah, so I guess the main challenges with recycling is that you're not creating thousands all at once. You have like a huge product variance coming in. Now, when you're building the batteries, you know, whoever's making them, whether it's VW or Jaguar Land Rover, you know they're going to make 10,000 in this space of time and they're all going to look the exact same. So that lends itself economically to, you know, to automation, because you just have to teach the robot, okay, you're going to have to do this same thing day in and day out at this speed. And once you've built that line up, then, you know, they can produce them and they can sell them in, you know, and they're selling cars at a very high cost. However, when you're at the other end of the process, you aren't the manufacturer. You're receiving a battery in, for example. It's a very complicated product and you don't know anything about it. You don't know how it was assembled. You don't know if it even can be disassembled. You know, if the companies are using things like glues, then it might be designed to be assembled, but it has been designed to be disassembled.
Yeah.
And even if you can destructively disassemble it, you still then, the next day, you maybe have a different pack come in, which looks totally different. You have to come up with a new strategy for disassembly. You have to use a new toolkit, and that's fine for a person to start learning, but then to be able to teach a robot and teach automation systems to do that and to deal with that product variance all the time is very, very time consuming. Yeah. And then you just have the return on investment is the big problem. So what you can sell a brand new battery for versus what a waste and recycling company get, the amount of money they get for the material or the black mass that they produce at the end of the recycling process is much lower in value to that brand new battery that's been sold at the beginning. So it becomes very difficult to justify that automation.
Yeah, that makes sense. So, how much does kind of regulatory, legislative changes that might be kind of coming down the line factor into this? Because I know I'm going to forget the terminology here, but I know that there was some discussion in the EU about basically like legislation that says that manufacturers of products are responsible for the entire life cycle of that product. So, like, if something like that came in, would you be expecting to see more interest, or are you seeing interest now from manufacturers who would want to be able to, like, reclaim and then disassemble their own batteries exclusively, which would kind of at least mean that you know what you're dealing with because they're all your batteries.
This really is, I guess, from a recycling perspective, the only way that we can really see a path to it being achieved properly. This is really looking at the product as a service business model. So if you force a company or they decide to set up a product as a service business model, which means essentially they're either buying or they're taking their components or their products back and then repairing them and trying to get them back out in the market, then, yeah, I guess the product as a service business model really lends itself to recycling and repair of a component. And that's really what this sort of legislation may help to drive in the future. If you look at the Rolls-Royce business model, so they have like the fly by the hour for their jet engines. And so because you're paying for the hour that you're using them, and then Rolls-Royce will take them back and they'll repair them and then they'll get them back out in service. There's an incentive for Rolls-Royce to produce the best quality engines that have the least amount of downtime and require the least amount of repair, and to keep them out in the air as long as possible, and extend their life by as long as possible. Well, when a company only has the incentive to sell a product once and only make money on it once, then they don't really have that incentive to keep a product out on the road, the batteries out on the road. They have the incentive to sell you the next car.
Yeah.
And so this sort of legislation, where maybe it doesn't drive the product as a service business model directly, but at least you would force the manufacturers to, as you say, buy back or take back their battery packs, and then to help save themselves money, look at reusing or disassembling the product, because, as you say, they only have to disassemble their battery packs. They don't need to deal with Nissan and VW and JLR and blah, 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 everybody's battery packs, and they know how they put them together.
Yeah.
And then this would also drive a better design for disassembly, because if they assembled it in a way where it can't be disassembled, then they're shooting themselves in the foot.
Yeah.
Things like battery passports, I think, are being floated at the moment as like the first kind of gateway to recycling. And that would mean that the manufacturers themselves have to at least supply some information about the disassembly process within the battery. And I think this would mean that, say, a recycling company who's buying those dead batteries in could either scan or plug in and read some information, and then would get like a disassembly recipe, say, from the manufacturer. The problem is, because we are trying to push, electric vehicles onto the road, and there's lots of like legislation around that coming from the government, it's also difficult on the manufacturers, because they've had to pivot suddenly from producing internal combustion engines to producing electric vehicles at a rate that maybe they aren't, necessarily happy with.
Right.
And so the government doesn't want to put limits on them in other ways.
Yeah.
When the government's, has set its own targets for meeting, net zero by whatever, 2030 or 35 or 50, whatever we're on now.
Yeah.
So, it's, I guess they're trying to strike that balance.
Yeah.
Yeah.
So talking more generally about kind of disassembly and, material recovery, you mentioned earlier about AI and computer vision. I guess they would be really useful for this situation where you're not just processing the same thing over and over again. You're dealing with a lot of variety in what's coming in. Can you talk a bit about how those technologies can help improve, speed, accuracy, or just commercial viability of these kinds of robotic automation technologies?
Yeah, I mean, it really, I think dealing with end-of-life products won't be possible without the advancements in AI and vision technology in general, really. There's, even as we talked about the example before with the end-of-line robotic recycling, and sorting robots, which is, a very simple robotic procedure. It's just picking and placing. But that would not have been possible without AI, to work at the speeds that these models work at, so that the robots can deal with conveyor speeds and all the different objects coming through. And that's true, again, for as complex a product as EV batteries. So whether that's identifying, where a bolt is or where you want to make a cut, to remove something, or whether it's a wire and if you're going to clip that wire, or just where it is physically in space relative to the robot. All of these now are done using vision technology. So it really, in the next few years, as we advance with that, it will make a huge difference to be able to deal with that product variance coming through. But again, it's very computationally expensive, and also a lot of manpower, really, to program something, to come up with, train machine learning models to deal with all the different products and techniques that you're going to be using in the disassembly process itself, that we have to come up with more efficient, streamlined methods, which are in the end economically viable for a recycling company to be able to say, yes, this is a useful product or machine that I can use, which will quickly disassemble a battery for me into a state that I can use for recycling or repair or recovery.
How much new innovation are you seeing coming out of universities in this space? Or is it kind of refining things that we already have, or are there new exciting things going on?
I guess there is a lot of work being done around EV batteries in particular. They are kind of flagshipped as the high value product where we can actually justify using automation for.
Right.
There are obviously lots of other products out there which could be disassembled, but unfortunately they're not seen as high value enough to justify kind of putting all this money into, or they don't have critical enough materials necessarily. I guess the obvious one is electric motors. So the permanent magnets are another critical material. So if we can extract them, then at least we don't need to go out and rebuy them off someone.
Yeah.
There is a lot of different innovations. I don't know if there's anything in particular that springs to mind, as is with robotics. A lot of the time it's like pulling together lots of different techniques and applying them, successfully. Whether that's using force feedback or force torque feedback to understand your cutting paths, or that you're actually gripping something or you're in the right place, and combining vision systems and different techniques to do that. Or task planning, understanding once you've taken an image, what's the right approach to disassemble that. These are all things we know innately as humans, that if there's a bolt there, we've got to remove it and then the lid will come off. But how do we train an AI model to be able to take an image and know that that's the right strategy it has to do as well? These are all the sorts of things that universities are looking at. And I guess where we fit in at the MTC is we don't necessarily have to look at the brand new and the novel. We're not driven by we don't have to be producing novel things. What we want is to try and produce the things that will actually work in the long term. So we can test out these different techniques and see, okay, that is the right strategy. And sometimes the right strategy is boring and it's just going to be sitting, coding it, telling the robot exactly where to go. And that's maybe not novel or exciting, but if that's the right strategy, then that's what we'll go for.
Yeah, absolutely. So are the kinds of robots that you're working with usually doing one specific task, and then there'll be a few different robots that each do one task, or are they more general purpose than that?
So for this cell specifically that we are commissioning at the moment, there are 2 robots which should be able to do all tasks. So It's very much a general purpose cell. And the idea is that both robots can pick and choose which end effector or which tool it's going to use and can perform either tasks rather than one robot doing the same thing over and over again. Obviously, that is a better strategy for automation. You want, a robot to be doing the same thing day in and day out. And if you're on the, building something on the other end of a manufacturing process, that's probably how you would design your system. But because we're at the tail end and the disassembly end, and the product is so unknown and they might be bashed, and so you don't know if it's in the right place, even if you knew exactly where it's supposed to be. The strategy we're taking is to assume that we don't know very much about it, and that we have to, check ourselves as we go, and each robot has to just be able to perform whichever task is suited best in that moment, rather than the same thing all the time.
Yeah. I mean, at least the robots won't get bored.
Yeah, hopefully.
Josie, it's been lovely speaking to you today. I've been talking to Josie Gotz from the Manufacturing Technology Centre. Thank you.
Thank you. Thanks for having me on.
Thanks for listening. If you enjoy Robot Talk, I'd really appreciate it if you could share the podcast, subscribe, and leave a review. It really helps boost the podcast, so thanks in advance. And don't forget to join the Robot Talk community on Patreon if you'd like to support the podcast and get access to some awesome perks, including behind-the-scenes updates and monthly bonus episodes. Visit patreon.com/Claire Asher to find out more. Next week, I'm chatting to Benjamin Mottis from Anibotics about robot dogs working in industry. Until then, I've been Claire Asher, and this has been Robot Talk. Robot Talk is brought to you by the Hamlin Centre, Imperial College London.